So Professor Len already gave us a little bit of a introduction last night on PowerSim. I'm just not everyone was there, so I'm just quickly going to recap your biography. So Professor Len is a system dynamics practitioner, microeconomist, and software engineer. His specialities lie in database modeling and system dynamics modeling. He has also worked in geographic information systems. He has built system dynamics models of the civilian nuclear fuel cycle, world energy consumption, bioenergy supplies, water basin management, workforce management, international conflict, and international migration. Many of these models were turned into applications. He was a member of the Office of the Chief Economist at Sandia National Laboratories from 1998 to 2005 and ended his career at those laboratories in March 2017. His current activities involve being the past vice president of meetings of the System Dynamics Society and actually the past president of software specialization in PowerSim Studio, group moderator at the International PowerSim Users Group, and developer of software engineering techniques applicable to system dynamics modeling, which is where I got to learn a lot from Len. Len has taught information systems, microeconomics at the New Mexico University. I think what I also just like to say, he's taught 7 of the last 9 system dynamics summer schools. Prior to 1988, he spent some time as an independent information consultant. So thank you, Len, for being here. I give you the floor to talk to us about the missing stage, which I think is so tongue-in-cheek because I don't think it should be the missing stage, but it definitely is. Thank you, Len.
Thank you, Corne. The first thing I want to do is say thank you to my friend Stefano. Of course, we met at a System Dynamics conference and have been friends ever since. So let me do the share. Hi, Stefano. Let's see, screen number 2. Hopefully now you can see that.
Yes, we can see it.
Okay, yeah, okay, let's start. So you'll see soon why I call this the missing stage. I guess my ideas around this stem from my career in software engineering, and it started to congeal, to gel, about 2007, 2008. So let me move forward here. Okay, let's have a short conversation. There's a relatively well-known article in the System Dynamics Review by Ignacio Martinez Moyano. Some of you know him as Nacho, and George Richardson. And it's called Best Practices in System Dynamics Modeling. And when it was released, I was so eager to read it. I encourage you all to read it. Maybe you can quickly copy down the citation, or someone can put it into the chat. So in this paper, there are 6 stages identified in this best practice process for doing system dynamics modeling. And you can see them here. Let me get my pointer. Problem identification, system conceptualization, model formulation, testing and evaluation. Wait a minute. It seems that there's something missing right here. Module use, implementation, and then design of learning strategy and infrastructure. So there's model formulation. Now let's take a look at the model formulation detail in that paper. Basically, what Nacho and George did is interviewed many experts, reviewed lots of papers, and looked for statements and recommendations from leading academics and practitioners. And my claim is only 2 of the statements in the model formulation section very weakly express anything about the model construction process or any guidelines. And I think those 2 statements are here highlighted in yellow. Assure dimensional consistency, that's very nice. Avoid cascading equation formulations. I'm not quite sure what that meant. Let me go to the next slide. So here's the terminology that I use, and all of you who have seen this before, it's late afternoon in South Africa, maybe it's time for a nap. But here's my terminology. I use the word module to describe a separate part of a model. Hopefully that part can stand alone with little exchange of variables between other modules. And a model is just everything you did, basically. All the code you wrote, all the variables you created to represent your problem. And finally, an interface is a conscious effort, right, to expose parts of that model to yourself, maybe for debugging, and to customers and clients. And when you attach an interface to a model, you have an application. So often when I speak to people, I use these specific terms, and I'm hoping that they understand what I mean. I have a little story. One of my managers said to me, "Len, I'm really eager to do a demonstration. Is the model done?" And I said, "Yes." And I sent it to him, and he said, "Where's the interface?" No, there wasn't one at that time. Okay, what's my motivation here? The methodology, our methodology or our method, it's benefited from so much work in model formulation, group collaboration, and model testing. I believe personally there's a missing stage, which I'm calling model construction. Okay, when we go to conferences like this wonderful South Africa conference or the international conference or any of the SIG or regional conferences, people report on models that they have built. But the readers of papers and reviewers of papers know very little about the model construction process. And from my point of view, very little about model quality. So I think it's appropriate. It's due diligence that we need to improve the quality of our models. So we need some kind of measures. What is a measure of quality? I had dropped this slide from the presentation earlier and decided to bring it back. So back in 2018, I reported on this where I downloaded about 325 models that were included in the conference proceedings from the year 2009 to 2017. And obviously I couldn't understand every single model and review it thoroughly, so I did the very simple quality check of dimensional consistency or unit errors. Okay. On this 45-degree axis, each red dot means that that model had none of its units defined. And notice these are models less than 1,000 variables, and that's actually an anomaly caused by VenSim. I can explain it maybe later. And here on the x-axis, anything that fell on that origin line is a model that had every single variable described with a unit, had a dimension. It could have been, they could have all been dimensionless, but nevertheless, someone took the step of defining. And then you see a spread here in the middle. Wow, I was in shock when I did this. And I did some other descriptive statistics I can tell you about later. So hold on a second, right? Are we creating models? And it's really nice that I'm following Stefano. An abstraction from reality, isn't that what a model is? Are we creating interfaces? Are we creating applications? Are we creating reports? What is it that we're doing when we apply this methodology? So here's another personal opinion. I pose that any application, now remember that means model plus interface, has these classes of variables. There are exogenous variables, which is data from external sources, typically. Endogenous variables, that's us. That's the system dynamics. That's where we have the expertise. There are variables that you may create specifically to enable your interface. You might be aggregating, disaggregating, putting on control objects like switches and sliders, graphs and tables, and you might need to create variables to enable that. And then finally, you may create variables specifically for testing and debugging. My claim is that those variables can easily be deleted from your model, and it will continue to run and produce reliable results. That's it. So I claim that any variable in your actual file, your Vensim, Stella, Studio, Insight Maker, Silico, whatever tool you use, should fit into one of those 4 categories. And then if you build, and when you build the interface, and this isn't meant to be a constant proportion, some number of each of these 3 will be displayed on the user interface. And you're making a conscious decision of what to display and not to display. Okay. So that box narrows and widens at your desire by category. Okay. So now we're finally getting to the core of this. Who can tell me what quality is? Rhetorical question. I looked it up in the dictionary. It claims it's a state of being free from defects, deficiencies, and significant variations. Do we know quality when we see quality? I think what happens is we see the lack of quality when we see the lack of quality. Why should we strive for quality at all? Right? It didn't fit in the 6 stages in the Martinez, Moyano, and Richardson paper. It wasn't in there. I claim, especially after having worked on modeling teams for many years, it reduces the cost of modeling. Another thing it does is it protects your reputation. If you know the famous shipbuilding case, Ingalls shipbuilding case, where the modeling was done by Ken Cooper, it's described in John Sturman's book. It develops trust with your clients, and even more importantly, for people like me who are consulting now, it leads to further work. Another hidden result is it promotes our methodology. Many of you may now know or may not know why models and full papers are not part of the international conference proceedings anymore. Because several leaders in the field said, we're putting things on our website that are of poor quality. Let's stop doing that. That was back in 2017. So what is it in the context of our models? Does anybody have a metric? I know some tool communities, and by tools I mean things like Vensim, Stella Architect, and Studio, have informal sets of quality characteristics or metrics. Even more importantly, what are the processes, right? Just like a recipe or an algorithm, what are the processes for assuring quality? In all the research I've done, I've found no universally agreed upon set. In my software engineering career, there are some famous studies looking at what were coders, computer scientists, subconsciously doing when they wrote code. Some very interesting work was done there. And are there any standards, right? This is the process, the steps, and these are the measures against. Again, no universal set of standards. There is a very, to me, famous D memo, but let's take a look at the date. January 15th of 2001. Gosh, that's more than 21 years ago. Someone wrote about standards. No, categories. These are just some that I use. Color and naming. Units, obviously, dimensionality, arrays and subscripts, modularity or partitioning, coding style, diagram layout, and then point out some coding pitfalls. Let's take a look at color. Those of you who have lots of experience can think back either to your work or work you've evaluated about models you've looked at. In my mind, colors are a personal or a team preference. It's fine to use color, but have a purpose and state it. Set up that scheme, publish it, and stick with it. I can't tell you how many models I've opened where I'll try to use terminology that all three model communities use. Connectors or auxiliaries are in the color green. Why? Are they trying to draw my attention to that? Or purple or yellow or red? Avoid hiding detail. I've seen people do this. They've actually taken model objects and colored them the same color as the diagram background. And now they've disappeared essentially from the model. They're there, but you can't see them. Don't add color to make things look pretty. I don't remember Jay saying anything about pretty models. Here's an example that we used from a MIT homework problem back from, I think, 1977 that had to deal with issues on the USA-Mexico border. So we literally colored the stocks, the flows, the auxiliaries or connectors or levels, whatever term you use, red when the variable spoke to things going on in the USA, green when it spoke about things in Mexico, gray for the border, all exogenous inputs were yellow, indicators or metrics were all black. Table functions, we added this crosshatch to the variable, and then we had this purple color to show that those parts of the model were the policy parts of the model. Let me go forward. Naming. This comes from that memo from 2001. The name should be clear and unambiguous. I think yesterday there was at least one person here who may have done Dynamo back when he was at MIT. Dynamo was limited to between 4 and 6 character variable names. Hey, it's 2022. We don't need that anymore. Don't use abbreviations. One of my jobs was to evaluate someone else's work. This concept, fuel type, was spelled 6 different ways in their model. Use acronyms very sparsely and only if they're accepted in the field. So kWh is widely accepted in the energy world. You don't have to write out kilowatt hours. Resist using digits in your names, unless, of course, the client calls things with digits like power plant 2, power plant 3. Please don't use special characters in names. First of all, they differ by culture, and second of all, it makes the equations difficult to read. And some tools don't even let you use them at all. So here is the list of recommendations from the D memo back in 2001. Constants should be in uppercase. Auxiliaries, let's see, those are connectors for Stella users, all lowercase, and flow rates lowercase. And stocks, the first letter of each major word capitalized. Those of you who use Vensim, I don't know if you know this, but Vensim has an option switch that will scan your model and rename everything according to this plan. If we have time, I'll show that a little later. I see we're running out of time. So here's a great model, and I know every single person today who's watching, and those of you who may watch this video, knows exactly what this model is about. Being facetious. And how about this one, which I think comes from a textbook with Stella examples. And how about this one? Is this any better? It might not be logically correct, but is it any better in terms of naming? So one of the very first steps in understanding model logic is to put names that you and your clients are familiar with, they're unambiguous. Here's another great one, and those models are reviewed for my 2018 paper. What is going on here? And you know, I've trained a lot of people in using PowerSim Studio and taught some university classes. Somebody submitting this to me for evaluation gets an automatic failure, automatic fail. But this was in a conference submission. It was obviously in Vensim, in case you didn't know. And I opened up the model settings window in Vensim. And this is the description they put for what this model was about. Nothing. Unacceptable. Okay, units. Every good tool has them. If your tool does not permit units, find a new tool. I also believe no model is so small it does not require using correct units. I've got some experience of 300 variable models that were used in a political setting here in the United States that had no units. When we did the dimensional analysis, we found that it was giving incorrect results. And third, it's very easy to fail a model. Those of you who are instructors, when you're evaluating work, if you want to lower the burden of evaluation, check for units first. If it's not perfectly correct, great, you stop evaluating that model. Use standard international units as much as possible, just because we're an international organization. So in some software, you might have to create a unit called foot, sort of the British unit of measure, which is approximately 0.3048 meters. Something we've done, especially when I'm modeling on a team and when we're modeling in the same problem domain, we'll create a completely empty model filled with units and use it as a template every time we start a new project. So we start a new electricity or energy generation model, we pull down the energy template. It's got kilowatt hours, watts, joules, all of those things predefined. Okay, arrays. Please, beginners, dynamics before detail. Don't start subscripting or arraying your model until you get one unit to work. There's a problem with arrays if you don't use them. If you start duplicating or copying variables, things can get really messy. Right? It adds more variables to the model, which increases the detail, and it might confuse the dynamics. Adding or duplicating uses more screen space. You know, how many times have a client said, "This looks like spaghetti"? And if you duplicate, any changes you make to your logic will have to carefully be made to all copies of the things you duplicated. So, detail typically involves repeating logic for sets of similar stocks, flows, or rates. Unfortunately, if that behavioral logic is different, you might have to duplicate. You might have to do something else. My recommendation here is please be careful. Modularity. This is back from my software engineering world, very famous book, The Practical Guide to Structured Systems Design. Cohesion is the strength of elements within a module. So imagine you're building an energy model and you need a population, something about population dynamics. You should build that on a separate view, a separate component, a separate tab, so that it's separate. And in fact, it's so separate that you might be able to use it over and over again in other modeling situations. Obviously, you have to change some of the values, but the model itself can be reused. And Paige Jones identified these different kinds of cohesion. System dynamicists don't need to worry typically about temporal and coincidental, but nevertheless, whoops, went too fast. You're striving for tight cohesion, reusability. Okay. Coupling is the second concept from Paige Jones, and that is, how related is one module to another? We want to strive for loose coupling. We don't want one module sending another module hundreds of values. If that's true, maybe those two parts of your model should be in one module. And I've got some pictures here. The mantra that software engineers used to live by, starting back in the 1970s, strong cohesion leads to loose coupling, and that's definitely a goal. So here's a picture of a relatively old but relatively well-known model called simulating violators. And I used some other kinds of software because I was an IT guy years ago to point out the modules. Those are the circles in color. The lines between them mean that this module is communicating with that module. The number on the line is telling me how many variables does that module pass to this one. I want to point out a couple of things. One, this module and this module do not communicate with each other. Okay, I think I've got a little tiny bit of animation here. Yeah. And then let me do a quick zoom. And you can see here that the population module and the social control effects, they're passing 18 values between them. And the punishment module and the legitimacy module are only passing 2. So the claim then would be that these are loosely coupled, more loosely than these two. What's your goal? Loose coupling, strong cohesion. Coding style, much like grammar and how we write, you all have access to the slides. I'm going to skip and just show you some examples. Do you prefer this? It's like getting your eyes tested. Or do you prefer that? I believe all the tools allow you to add carriage returns and make your logic easily understandable. Do you prefer this? Or do you prefer that? And by the way, the colors here, this is something I stole from our summer school session. Everything that was in blue, that came out of a PowerSim Studio model, and things in red came from a VenSim model. Okay, how about this one? Probably a beginner who didn't know how to use subscripts, but my gosh, this is difficult to read and understand. The names are a little bit difficult. I mean, out of context, B to C means what? I to B means what? Out of context. Hopefully, if I spend enough time here, I'll read, oh, this must be infants who are aging into babies, babies who are aging into children. But why make it difficult to evaluate? Here's some more. Like I said, it's real easy to find examples of poor quality. Here's one I sure would like to know what X and Q are, and CVP and P and I. Here's another one I had to put a studio one on that showed an actual error in the variable. I see it. Oh, that's an English language word deviation. I don't think I've ever read a textbook that has underscores between the words. And then why are these capitalized? I don't know. So here's what I recommend. Some of you may have seen my seminar, webinar from the Society about 14 months ago. I call it outside-in approach. Get all your constants on the screen first. Get them named, get their units on. And here are all the constants in this simple model. Then get your stocks defined. Then you iterate between rates and auxiliaries. Whoops, sorry, I hit the mouse too soon. It really helps a lot in quality model construction. It helps with managing units, logic, all kinds of things. I'm getting almost out of time. The advantages, if you add constants first, it distinguishes exogenous from endogenous. It indicates potential opportunities to grow model scope. So I have this habit, when I open a model, I look to the constants and I look to the graph table functions. And I think of those things as opportunities to grow the model scope, basically to replace constants with other small models or add some endogenous behavior. When I look at graph table functions, I think, wow, maybe another small model could substitute for a table function sometime in the future. It also highlights potential policy variables, the so-called sliders, right? It helps us up front to determine the model units. Adding stocks next might allow unit inheritance, especially when setting initial stock values, obviously model transparency, and then you iterate through auxiliaries and rates to manage your logic, reinforce the unit inheritance, and enforce the methodology. Okay, the hard part, you may be asked to evaluate models. Many of you have done that for this conference. What are the measures? First of all, does it run? Of the 325 models I evaluated back in 2018, about 35 of them would not run. Then it has no unit errors. That's my second check. If then else, use sparingly. Now it's hard. It's got to spend a lot of time. And then I have an ellipsis here. What are they? What are those measures? We don't know. Right? This is for construction quality. We don't know. So here's a challenge. Given a model, can you point out the quality problems? And can you fix it? Even if you're not a specialist in the problem domain, can you fix the construction quality? So just a recommendation, if you really want to do that, go to the Society page, go to past conferences. I think you have to go prior to 2016 or 2017 to actually find models in the conference proceedings. And it might take a few tries to find one that you have the software to use, but it's just something to do. I think it makes you a better modeler. And that's it. I think I've got time for questions. Yeah, that's the last slide. Let me go out of presentation view and come back.
Thank you so much, Professor Malczynski. There's so much you said that we would like to, I think, discuss. There's already a hand up from Dr. Burtis. I'm going to ask him to take the floor for us and go ask first.
Absolutely. Maybe he's still muted.
Okay. Yes, now I'm still muted.
Okay.
Len, thank you very much. The one thing that I did miss is, explaining how to document models, because one of the things that I find extremely useful, and I'm very bad at it, is if you write code, you've got to document, especially where you make assumptions,
Yes.
to try and explain where they come from. And I find one of the useful features of some of the packages is that you can go in and actually put that description of the model in there and explain your logic and your base conditions, which means that when you do change it, you've always got something to refer back to.
That's excellent. Yeah, the three, what I call the big three, right? Stella, Architect, Vensim, and Studio all have the capability to do that, right? If you're a Vensim user, I highly recommend using the tool SDM Doc, which is free on the Society website. Hopefully someday in the future, it will also work seamlessly with Architect and Studio, but the fellow who developed SDM Doc has retired, so he's no longer supporting it or coding. But you're right. The other thing I don't like is when people put documentation in the same section where the code is. I think it should be in a separate documentation area. Go ahead,
Absolutely.
Corny.
Yeah.
That's good. Dr. Witte, did that answer your question? Are you happy with that question?
Yeah.
You can
Yeah,
ask
no,
a question
I
again.
agree. I think we're on the same page on that one, 100%.
That's great. Juliana, I would please like to welcome you and share with your comment or your question.
Thank you so much. Thank you for the presentation. My name is Juliana. I'm fairly new to system dynamics, and I've been trying to engage with a lot of the conferences, seminars, or presentations taking place just to try and find my feet and get a bit more understanding. I find it extremely interesting, and I found this particular presentation extremely interesting because I've reviewed a few journals and looked at a few papers that have been published, and I've always struggled to understand how the model came together. So I appreciate the information that you have shared. But building on that, are there any programs currently available that actually hinge on emphasizing the importance of coding and just putting across the different models in a way that they are a lot more understandable and easier to break down, to make it easier for some of us that are just stepping into the field? Thank you.
That's an excellent question. I started doing a lot of this before the internet was really what it is today. So a couple of things I wanted to say is there's a lot of material on the internet, not only models that you can download and look at that are of good quality, but opportunities to educate yourself either at your own pace, if you have the diligence and the time, or formal classes that you can attend. Probably the best one-stop shopping for that is the System Dynamics Society website. Let's see here. I'll put, if I don't want to promote the tool that I use, but let's see. Oh, there's a note from Josephine about SDM Doc. Let's see. If you go to Mind's Eye Computing, whoops, I'm putting it in the chat.com. I think I spelled it right. We've probably got 100 models there that you can download for free. Almost all of John Sturman's textbook models, of course, with his permission. George Richardson's teaching models, Hartmut Bosel's models, Hartmut from Austria, that you can download that are well done with good variable names and are all dimensionally consistent. So trying to find other people's good work and understand it. And the models are all separated by topic.
Perfect. Thank you so much. I appreciate it.
You're welcome.
That's a really good question. I'm so glad you're asking, because I'm sure there's a lot of people who have similar adventures they're taking on with System Dynamics, which I'm very happy about. So please, Juliana, please do contact us if you want to learn more and you're struggling to connect. I think that's the one thing about this community, is we really love seeing people learn and grow. Any other questions that may have come up? I'm sure there's at least another question. We have a few more minutes left before we break for today.
I don't think, Corne, we can't do a polling here, but I wonder if maybe the easiest way to ask this question is, who out there attending today is not using Stella, Vensim, or Studio? Is anybody using one of what I might call the second tier tools?
That would be very interesting to know.
I can try and run the poll quickly.
Oh,
I can create
thanks,
one
Len.
quickly.
well, and I also don't want to take time away from, you know, one of my best friends, right? Who's next? Josephine.
Well, yeah, we are going to take a break quickly because I think
Oh,
we all
good,
need
good,
it.
good.
And then Josephine is going to come teach us, which I'm also very excited about. Thank you, Nalini. Dr. Pillay is like Superwoman in the background always, and in the front.
And,
But then,
you know,
sorry, yes.
Having come from the software world into the system dynamics world, I was in shock. I mean, I had to evaluate, you know, code back in those days, COBOL and languages that are now essentially dead. But my gosh, you know, I was in shock. Some other instances, I've gotten code in other languages, not system dynamics, and tried to convert the models into system dynamics and found inconsistencies all over the place. Logic inconsistencies, data, because those paradigms they don't guide you through the modeling process, I think, as well as SD does. And
Can I just have that question quickly?
Yeah, maybe who's not using Stella, Studio, or Vensim? Is anybody using the lesser known tools? I'm just curious, because then it becomes harder.
Does Dynamo count as a lesser known tool?
But we're talking about this century, Andres.
Oh, so you're also not on my Fortran side then?
Yeah, same for me. Fortran, right? Okay, so probably no one is, but it just makes it harder. The communities are smaller. The access to papers and models in those languages are harder to find. Maybe someday that won't matter, but I think it does matter now. The volume of information is definitely in the big three. Oh yeah, I forgot to say, join your user group. Whatever tool you have, join that user group. All three of the big guys have active user groups. A great place to learn, a great place to get help. I've had people email me entire models to help me get work done.
That's a good suggestion. Thank you, Professor. Nalini, thank you for starting the poll. I see there's actually 9 people who responded already. There's only one person who's said yes so far. The rest of us have all said no, which is
just curious. Yeah. Thanks, Nalini.
Sorry, Len, I think we should make a punt here. So the other place to learn is to come and join the competition next year, and we'll take you through good practice.
Yes, I agree. Yeah, I said this yesterday. It's definitely worth repeating. Thank you so much to the South Africa chapter. I mean, this is what changes the world, believe me. This is the kind of thing that changes the world. Access to the conference, access to the people at no cost right now, except an internet connection. Very, very important.
Thank you, Professor Len. That means a lot, especially coming from you, who's already changed the world in many ways.
Well, I see Stefano there, and he and I have a long history about this quality stuff and modeling and all the work the Italian chapter has done to help people all over Italy read in their native language, right? You're muted, buddy.
Yeah.
Sorry, yeah, thanks for this, but really I want to stress again how helpful these events are, and I want to copy Len, and I really would like that all chapters and SIGs would be able to organize these events, and we should. We as the Italian chapter have done this extensively over the years, by localizing content, by organizing events, and by promoting also systems thinking and system dynamics also through European research and educational projects. And I think that this should be done and pursued pretty much by all chapters and SIGs. And I really welcome this kind of events like you have done here with this conference. So many compliments, and please go ahead.
Stefano, the other thing is, and you're well aware, the 3 people I see on my screen, they all have day jobs.
Yeah, we all do.
They're putting in a lot of extra time to do things like this. In fact, the entire society runs on volunteer power.
Yeah, absolutely. And I would say that these are the people we need in the, not only in the society, but in the world, because we have to eat at the end of the day. We have to carry on with our families and daily lives, but at the same time, we really need to find a way to make other people aware of how to potentially improve our world, and systems thinking and system dynamics have this potential. The only problem is that we need to spread it out more and more.
Absolutely, and thank you guys. It's the effort by people like you that actually help us then to do what we want to do and to achieve the objectives of growing the skills base in South Africa and in Africa. We really appreciate the effort and the time that you guys take, and we hope you will work alongside us in future for other events. And I'm sure a lot of people are so appreciative of the efforts that you guys make to try and help us transfer the knowledge and learning lessons to them. So thanks again.
Welcome.